Hello. So in this video I'll be talking about the unit circle that is used to define the trigonometric functions sine, cos, tangent and other trigonometric functions which are basically the reciprocal of these functions that I've just mentioned. Now this video is going to be the first part in a series of 4 videos where I will go over trigonometric functions, trigonometric identities and how can you remember them. Some basic tips and tricks for you to remember the identities essentially. Now this unit circle that I've drawn right here is essentially where all of the trigonometric identities in one or the other way are derived from. So a fundamental understanding of it is required if you plan to memorize all of those identities and properties of trigonometric functions. Okay, so that is why I'm starting this series of 4 videos with a summary of this unit circle, how does it work and how does it define the different trigonometric functions. Now in class 10th we have studied trigonometric ratios, okay, ratios, and let us do a small recap of that. So on the right hand side of my screen I have drawn a right angle triangle. Let me label the right angle first, okay, and let us say the hypotenuse of this angle makes the hypotenuse of this triangle makes an angle theta with the base, okay, and let me label the different parts of this triangle. So the base is labeled B, the perpendicular is labeled P and the hypotenuse is labeled H, okay. So as per our standard trigonometric ratios definition, the sine of this angle theta is written as the ratio of perpendicular upon hypotenuse. So that becomes P by H. The cos of this angle theta becomes the base divided by the hypotenuse. So that becomes B by H. And the tangent of this angle theta is the perpendicular divided by the base, so that is P by B, or it is also written as the ratio of sine theta by cos theta, okay. That is our standard trigonometric ratios definition. But now we are talking about trigonometric functions. Trigonometric functions are an extension of trigonometric ratios, and let me do a simple activity to illustrate what the difference is. If I asked you to calculate the sine of 1000 degrees, that would sound absurd, right? If you were just familiar with the trigonometric ratios definition, because you will obviously say, how can I achieve an angle of 1000 degrees within a triangle, right? Because the sum of all the angles of a triangle can be maximum 180 degrees, so how can I end up with 1000 degrees? And I would say, yeah, that's a fair point, but let me show you something. Okay, so I have just pulled up my calculator here, scientific calculator, and it is set to degrees, okay. So let me enter 1000 degrees and let me take the sine of this angle, okay, and you can see it gives me a value of minus 0.98. So there's obviously something else going on right here. If 1000 degrees is not possible in a triangle, but still the calculator returns me some value. So how is that possible? That is because this trigonometric ratios definition is a little too specific, okay. Now we are talking about trigonometric functions, and this is where the unit circle comes into play. Let me just remove the clutter here. Okay. The more general definition which is used everywhere in engineering. And for instance, this calculator that I just pulled up is of trigonometric functions, and trigonometric functions are defined, let me write that down. Trigonometric functions are defined by the x and y coordinates of the unit circle. Let me pull that. Okay. So unit circle has something to do with trigonometric functions, which allows us to calculate the sine of, say, 1000 degrees. Now let us talk about the unit circle before we dive into the actual trigonometric functions. In the language of mathematics, if we say if something is unity, we mean that it possesses a value of 1. Okay. So if I say x is unity, what I mean that x has a value of 1. Okay. Along the same lines, this unit circle is defined to be a circle which has a radius 1. Okay. R1 means radius 1. So the length of any line drawn from the origin to the arc of this circle has a length of 1. Okay, that's just how definition is. Okay, so unit circle is a circle with radius 1. Now let me draw a line real quick. Okay, and let me label the points. The origin is called as O, and the point where this line intersects the arc of the circle is called A. Okay. Now the x and y coordinates of this point A are going to be the trigonometric ratios cos theta and sin theta respectively. And let me show you what I mean by that. Let me draw some imaginary lines from this point on the x-axis, which I've just done right now, and on the y-axis. Okay. And let's say that this line OA, which has a length of 1, makes an angle theta with the x-axis. Okay. Now you can see this becomes sort of a triangle once again, and we can use our old trigonometric ratios definitions to calculate some trigonometric ratios. Okay, so here this radius OA is actually the hypotenuse of this triangle. Let me label that as h, which equals 1. Okay, this vertical line right here is the perpendicular of this right angle triangle. It's called as P, and the base of this triangle is labeled as B. Okay. Now some standard trigonometry. What is the sine of this angle theta right here? Sine of theta is nothing but the perpendicular upon the hypotenuse, which is P over 1, because the value of hypotenuse is 1. So P equals sine theta. Okay. The value of this length is sine theta. So the y coordinate of this point has to be sine theta. Right? Let me write that down. We have the y coordinate as sine theta of this point A. Okay. Along the same lines, cos of this angle theta is the base upon the hypotenuse, which is P over 1. So the base equals cos theta. This length is cos theta. the x coordinate of this point A, the x coordinate of this point equals cos theta. Cos theta. So in general we can say that the x and y coordinates of any point, be it this point or be it this point on the unit circle, would have the coordinates in the form of some cos and some sine. Now obviously the signs vary, and I'll show you why that happens, but this is just to illustrate how the x and y coordinates of any point on these arcs come out to be sine theta and cos theta respectively. Okay, let me clear this up. So we had y equals sine theta, the y coordinate of this point equals sine theta, and the x coordinate of this point equals cos theta. This was for the first quadrant. Okay. Now let us draw another line from the origin to the arc of this circle. Okay, and let us say that, let me use a different color. Let us say that this line makes an angle of, I don't know, alpha from the x-axis, and let us call this point as B, and let me draw some imaginary lines just as before. Okay, so as I defined earlier that the coordinates of any point on the unit circle are defined by the trigonometric functions cos and sine respectively, we can apply the same principles here and draw some conclusions. Okay, so now the x coordinate of this point P is on the minus x-axis, right? So it is going to have some negative value. The y coordinate of this point is on the positive y-axis, so it's going to have some positive value. This is just how the second quadrant works. Okay, since the x coordinate of this point P is negative, we call the x coordinate of this point as minus cos theta. Okay, again, since the x coordinate of this point P is negative because it lies on the negative x-axis, we call its x coordinate as minus cos of alpha. Okay, so we have a negative sign here because its projection on the x-axis is negative. It lies on the negative x-axis. Okay. And as far as the y coordinate is concerned, it is still positive. So the y coordinate of it becomes sine alpha. Right? The x coordinate is minus cos alpha because it falls on the negative x-axis. Y coordinate falls on the positive y-axis, so it is positive, which results in the coordinates being as minus cos alpha and positive sine alpha, which is also why we say that sine is positive in the second quadrant and cos is negative in the second quadrant. Now let us draw another line and let us say that this line makes an angle beta with the x-axis measured counterclockwise. Okay, let us call this point C. So again, the x and y coordinates of this point C are going to be the trigonometric ratios themselves, but now we can see that the projection of this point C, the x coordinate of this point C is going to be negative because it lies on the negative x-axis, and the y coordinate is also going to be negative because it lies on the negative x-axis. So we can write the x and y coordinates of this point C, as minus cos beta and minus sine beta. Okay, and this is the third quadrant. This is why we also say that both cos and sine are negative in the third quadrant. And let us say that this line makes an angle gamma with the positive x-axis. Let us call this point D. Again, the x and y coordinates of this point are going to be the trigonometric functions by the rules of triangles. So now you can see the x coordinate of this point is going to be positive, but the x coordinate is itself the cos of this angle gamma. So we can write the x coordinate of this point as cos of gamma. The y coordinate is going to be negative because it lies on the negative x-axis. So the y coordinate is going to be negative sine of gamma. Okay. So that is why we again say that in the fourth quadrant the cos function is positive but the sine function is negative. Okay. Now this unit circle that I've drawn right here forms essentially the foundation of many trigonometric identities that you will come across in your class 11th NCERT mathematics textbook. And I'll show you this in later videos, if you use the unit circle to derive an expression for, say, cos of x plus y, where x plus y are angles, not the x and y coordinates, you will essentially be able to derive any other identity in some way or the other. This is where everything starts from. So that is why the understanding of unit circle is absolutely crucial. What about the tangent function? In the first quadrant, we have sine and cos both as positive, so the tangent is also positive. Okay. In the second quadrant, we have sine as positive but cos as negative, so the tangent is negative. In the third quadrant, both sine and cos are negative. Tangent is nothing but sine over cos, both the negatives cancel out, so the tangent is positive in the third quadrant. And in the fourth quadrant, again sine is negative, cos is positive, so the tangent in the fourth quadrant is negative. So we can establish some periodicity of sines of these functions. Okay, so in the first quadrant, we have the sine, which is the y coordinate of all of these points, as positive. Sine is positive, therefore its reciprocal cosec is positive. We have cos, which is the x coordinate of all of these points, as positive, cos is positive, so its reciprocal secant is positive. And since sine and cos both are positive, their ratios, which is tangent, is positive, and its reciprocal, which is cotangent, is also positive. Okay. In the second quadrant, let me label this. This is the first quadrant. In the second quadrant, we have sine is positive, which is because it is essentially the y coordinate of these points. Y coordinates are positive. Sine is positive. Therefore, cosec is positive. Cos is nothing but the x coordinates of these points, but since they lie on the minus x-axis, they are negative, so cos is negative, therefore secant is negative. Tangent is nothing but the ratio of sine over cos. Cos is negative, so tangent in itself and its reciprocal cotangent is negative. Okay, let me label this just so you do not get confused. It's positive. Okay. In the third quadrant, sine is negative because all the projections are on the minus y-axis. Cosec is negative. Cos is negative. Therefore, secant is negative. But tangent is the ratio of sine over cos. Both are negative, which cancel out. Tangent is positive. Cotangent is positive. And in the fourth quadrant, we have sine is negative because again all projections on negative y-axis. Cos is positive because all the projections are on the plus y-axis. Secant is positive, and tangent is the ratio of sine over cos. Sine is negative, therefore tangent is also negative. Cotangent is also negative. Okay. Now I will be referencing this unit circle in my future videos because this is where every trigonometric identity starts from this, and if you want to understand the identities, you should be absolutely clear with the unit circle. Okay, so I'm adding this segment a little later because I absolutely forgot why I mentioned the sine of 1000 degrees. The reason is this: if I draw a line at 1000 degrees, it's just going to return in the fourth quadrant, right? And you can do the math. 360 degrees of revolution brings you back in the first quadrant. Another 360 degrees of revolution, which is 720 degrees, brings you to the first quadrant, and another 360 degrees of revolution, which equals 1080 degrees, brings again to the first quadrant. But we want 1000 degrees, right? So that's 80 degrees lesser than this line itself, so that this line at 1000 degrees is going to be in the fourth quadrant. Okay, no matter how much angle you cover, you will essentially land up in the four quadrants because that's how circles work. Okay, so this line revolves a bunch of angles and it arrives at 1000 degrees. Now the sine of this 1000 degrees is going to be the y coordinate of this point. Okay, so as per the calculator, it comes out to be minus 0.98. So that is why you can take the sine of such massive angles, because it's not related to your old trigonometric ratios based definition of triangles, but now we are talking about trigonometric functions, which is defined using the unit circle, and to be more exact, it is defined using the x and y coordinates of the points of the unit circle. So that is all there is to it, to the unit circle. I will be elaborating on the symmetry of these functions when I start talking about trigonometric identities and how trigonometric identities come to be in relation to this unit circle. I'll be talking about that in future videos. For the time being, if you liked this video, if you found it helpful, you can press that like button, and you can also consider subscribing to this channel if you are interested in viewing such content. So I'll see you next time. Bye.